but if you have some from the region, please follow me, and also from other countries, of course. So we will, we are ready?
Yes.
We are just starting the streaming. The first host is first thing, dear host, so Professor Domenico Otranto from the University of Bari. We don't need any introduction because probably you know, for sure you know, because as written over 700 publications on parasites and zoonosis. And we asked him a very hard work to summarize in 20 minutes and no more than 20, Domenico, the most emerging parasitic zoonosis. And then we will go further, and we will have another host from Bari University, which is Professor Martella, which will do exactly the same on the virus. So please, Domenico, welcome, and good
luck. Good luck. Good luck. Thank you, Antonio. Thank you very much for your invitation. That is a really great pleasure. I will tell you when to start with the countdown. And no, that's really a pleasure to have been invited here. And I would like to thank Luigi and Alberto and Antonio and all the organization, as well as Patricia for organizing all this event and for allowing me to talk and asking me to talk about vector-borne parasitic zoonosis from the So since it's impossible to deal with these in 20 minutes, with all this not yet started, I decided just to discuss about the epidemiology and the control of some of these parasitic diseases, which are those that are not discussed or have not been dealt with within other talks. So I will not talk too much about leishmaniasis. And specifically, I will provide you with some experience on parasitic zoonotic vector-borne pathogens that I met, because of the beat usually parasites over the last 20 years. So I'm also very happy to see the Professor Scala here. I will have you problem. So you could start with that. Because while talking about parasitic zoonosis, we know also that the concept of one started when Hippocrates in 5th century before Christ described or observed that the malaria, some malaria cases in humans, some malaria cases in humans, which were related with the mosquitoes, the presence of mosquitoes in swamps. So this was the first idea of One Earth, where the environment, animals, and host, and the human part were related. And if you also consider that the first scientists who declined and who defined One Earth was Schroeder in the late 18th, and you understand he was a parasitologist, and you understand how important are vector-borne pathogens, parasites in the concept of One Earth. So these are some examples about that. And you also know that the evolution of vector-borne diseases over the last last century.
Riesce dalla presentazione, altrimenti non vuoi streaming.
Yeah, but if okay. I have
here is okay, but it's not going.
Okay. The evolution of I guess the evolution concept of vector-borne diseases over the last century was quite interesting, because from the anthropomorphic vector-borne diseases, so those transmitted from within humans after the post-revolution, the post-industrial revolution, the zoonotic the vector-borne diseases have increased the interest because yesterday Gab told about the high relationship of domestic animals with humans. and also the number of pets. I have a slide right soon after. And also the parasites of dogs and cats supersede the interest of that, supersede those of livestock because of breeding system, for example. Just consider, for example, that 1/3 of the global animal health market is represented by parasiticides, and 4.5 billions of euros are just those for companion animals. And this is an increase, just because we know that it's very important that the parasites have an important role, and the revolution in the control of vector-borne diseases has been represented in 2014 by the advent of isotonides. So we'll try to discuss about that. And you also know that the increase in dog population and the increase in treatment against parasites in dog population is really important and is an important factor and an important part of the market, even if, according to some statistics, about 50% of dog population, dog and cat population in Europe are not properly treated. So, because of competence of the owners, as well as because they usually do not treat properly our dogs, veterinarians sometimes it happens like that, mainly because of the use of isotonides, which seems to be the panacea, the most important drug, the only solution. And you will see that cases of canine leishmaniasis are at increase because of this assumption that is incorrect. So we know that when talking about arthropods, and that may move a little bit, yes, because here it's much better. When we talk about the epidemiology of vector-borne pathogens, we have to consider the local risk and the broader risk, and as well as at local risk, the competent vectors, the presence of competent vectors and of animal reservoirs. This is a very important also for modeling parasitic disease, because some vectors are much easier to be modeled in their distribution than other vectors, and also biotic factors and abiotic factors like animal vector population density and land use and social changes, increase in travel and trade, and also wars. For example, we had in 2023 a very nice article which by Bayer in parasites and vectors about the increasing number of diabetes cases in dogs imported from Ukraine to Poland. So this is just an example. But importantly, when we talk about zoonotic vector-borne diseases, we have also to consider the environment and the place and the economic settings where we discuss about that. And we do know that the poor living condition of human populations is related, for example, with the stray dogs. The number of stray dogs has also been assessed. This until some years ago, we got as well. And so it's very important to know which kind of priority from a public health standpoint we have to give in different contexts. But just trying to give some ideas about the complex interactions with epidemiology of vector-borne diseases, parasitic vector-borne disease. We do know that there are different components of this complex interaction. And we also know that the canine vector-borne diseases represent a challenge because of the treatment, because it's very difficult to treat that when the infection happens. So it's much better than prevention when we talk about with control. And also the diagnosis is may represent a challenge because of the limitations to different serological molecular tests common with pathogens, and also the epidemiology of vectors. That's why I try to summarize my thought in three different parts. That is the epidemiology, the diagnosis, and the control. In the epidemiology, while talking about some examples about the changes in the epidemiology of parasites and other diseases, we have to talk about chain distribution, host vectors, and the susceptibility of new hosts as well as the presence of new reservoirs. And the typical example is represented by the distribution of canine leishmaniasis and of diarrhea, which changed a lot when in 1990 we had a new vector, the Asian mosquito, Aedes albopicus, introduced in Italy. Therefore, we noticed and we knew that since from here, the diarrhea in northern Italy was distributed in northern Italy in the Po River Valley, because the biology was mainly linked to good experience, which is a mosquito of swamps, basically. From the northern Italy, we had a change distribution pattern of diarrhea also in southern Italy, when it was introduced Aedes albopicus. And this pattern was also confirmed 10 years later from in a survey that we conducted on 10,000 dog samples from all Italy from 2009 to 2019. That was also explained, and it explained also the presence and the retrieval of very high prevalence of diarrhea in some areas of southern Italy in legend. Why? Because also another important component, you see how the human behavior and also the veterinary practice is important, because in this area we do not treat animals with, in this region, that not treat the animals with chemoprophylaxis. So we had up to 42% of prevalence of infection, some shelters of legend. And meanwhile, also with Emanuele Brianti from Sicily, we found that we worked in this small island of Vinosa, which is 5.2 kilometers, 3 kilometers in southern Sicily, and we found that very close environment, the very high prevalence of diarrhea by the in dog populations. In that case, we decided also to perform the first, I would say, because it's not in literature, eradication program in all dogs by treating these animals by doxycycline and mobilization over 2 years. And all these studies were related also with the studies, investigations that we carried out on the population of humans, and we found up to 7.7% positive human inhabitants in the small island of Vito. So this is an example of one hand and also of distribution change, distribution pattern. But one of the most paradigmatic examples of this changing distribution pattern for parasites is represented by this parasite, which is more or less one of my favorite parasites, that is Stintino, which was considered an oriental eyeworm. It was a Chinese eyeworm. It was completely infects also human beings. The Chinese is a major problem in the humans. In Europe, the first case was 1989 by Martella, reported by Martella, and in 2000 we found in the early 2000 we found a prevalence in the Sicilian region of up to 42% in dogs. And the first question it rises to us in 2003, this first up was current status of the observation plants in the living dogs, cats, and foxes of Italy, a constant or a parasitic disease of the heart. So we understood immediately that the most important components for replying, answering this question was to know exactly which was the vector of the Laxativia, because it was still unknown. And that's why we started our studies in this small village in the middle of nowhere in Basilicata, Vito, where we found up to 60.4% of prevalence of terrazza. This is a major place, a wonderful place where we run the parasitology summer course since 10 years, which is a parasitology course for training people, veterinarians, physicians, biologists, on vectors and arthrovectors and transmitted pathogens in Mediterranean countries. You see that over the last 10 years, well, we stick to many colleagues from everywhere in the world came, and usually we do very practical course, lectures. Antonio Martella, he was I think that we were at the first edition, and then became also professor at that course. But it's very practical course, really a practical course with the collection and education, and also God is always present there in the course. I think course as professor. And in this place, we found that the vector of Terrazza that was Fortica variegata, which is a Drosophila fly, which has a very nice behavior. It feeds on lacrimal secretion, so it feeds on lacrimal secretion of human beings, and they feed on the first stage larvae, which are raised by the nucleus of the nematodes in the eyes. And then they develop these larval stages up to third stage infective stages to another infection in another receptive host. And so you see, this is the biological life cycle of Terrazza. Why this is important? Because when we found these, we discovered this parasite, this vector, we immediately started to be worked on the predictive models for understanding and for predicting the potential spreading of this parasite with the ecological niche, according to the ecological niches of Fortica variegata in other parts of the country, and also Europe. And in 2005, we predicted that many parts of Europe would have been suitable for the distribution of the Fortica variegata and of Terrazza. This is an example of the arthropod which is suitable to be used in a model for predictive model for this kind of studies. This kind of studies. It's not the case for sandflies, or it's not the same level for sandflies. And so when we published this article, we didn't know that we had not crystal ball, but we didn't know that in a few years we would have the distribution of Terrazza Gasparine all over Europe. You see that today Terrazza is spread in all Europe. And this is what I had not done. But it was because some hunting dogs from Southern Italy, from Basilicata, moved, and they used to be moved for hunting competitions in Spain, where we had the first cases, and then from Spain to France. So we can track also by molecular targets. So these are very unit one gene was studied, and haplotypes distribution was studied quite intensively over this field. And the problem is that when we work as scientists, we have some ideas of these parasites, and we used to consider that a local level, a European level, but we do not give, as parasitologists, veterinary parasitology, enough importance to what we say. When we had some cases, important cases in the United States, just 3 important cases in the United States, I was just contacted from many journals and other many journals and in UK, and they discovered this parasite that was prevalent 60% prevalence in Moréna. It was just 3 cases, important cases. So you see how perception is important and how important it is also to understand not what we know about ourselves, but just how it is going to evolve, how it's going to have an idea, which is the prediction of the distribution according not just the global warming or increased technology. For example, in the United States, we found that the 40 variegati in the United States was suitable host for the razza Libera. And in this first article, we wrote that the razza Libera would have been present in the United States. It was happening in 2020 and now in 2024. So it was just predictable. And I think that I'm here. I can stop, I can do more, I can discuss with you what I said. Bravo, listen, I know. Alberto. No, you could give me support. No, but sorry. No, but I can stop, or I can just have a small other part.
I think you can.
Yeah, I just gave you another example of a new parasite. A new parasite that is of human concern is a parasite that is Onchocerca, is a parasite of dogs. Nobody worked on that and nobody knew about that parasite. And just because of the diagnosis of this parasite, which is a peptideroid, it does not, this figureroid is not diagnosed by the retrieval of the detection of first stage of microfilari in blood, but under the skin. And so that's why this parasite was never reported in dogs and in cats. The problem is that when we do this, and the reason is because this parasite is diagnosed by skin signal biopsy, and you see that is in dogs very often is in the retropower. So that's why you do not see it. And when we found for the first time in 2011 the first human case of this parasite, zoonotic parasite, soon after, also physicians and ophthalmologists started work on that, and they identified in Iran as well as in the United States, in Morocco and other places, these parasite and cases of human cases of this parasite. And it was included also in the CDC, by the CDC as a notifiable disease of dogs. So this is why we, in that case, diagnosis and not proper diagnosis of Onchocerca lupi may have caused, just may have made this parasite neglected. Indeed, we may have some clinical cases with non-relations. There is no any treatment for them, just starting treatment. Also in humans, there is just starting treatment. And this is the clinical cases that are diagnosed. But when we diagnose in the same identifiers from where canine onchocercosis or non-relations were reported, when we diagnose other animals in the others, we found the prevalence up to 7 or 8.4% of dogs. And this is really a public health problem for humans, because you do not see that this parasite, but you may still have some cases of Onchocerca. I think that is that's it, because I had other slides, but it's really a little bit tight. So
I think that maybe is better to use these 3 minutes to see if there are any questions from the floor. Any question? If there are no any questions, you can use more slides.
yeah, there is a question.
Basically.
No, because it's not.
3 minutes.
Yeah, what I say. If there are no questions, you can continue.
Oh. I just give a talk that without, you need epidemiologic control of parasitic disease or vector diseases. Okay, that's something also very recent. I will go through my presentation on that. And it's Ehrlichia canis, first case of Ehrlichia canis in Europe that we are going to publish human cases of Ehrlichia canis in humans. We had another case reported from Venezuela, and this is something that should be published in the United Infectious Disease quite soon. And this may be related also with the vector, which was sanguineous, because we know that we have a different taxonomy and different species of vector within the cellular context. And the last parasite I don't told you, and I think that is really, really interesting for all people working on leishmaniasis, is Leishmania tarentula. We do know that this species of Leishmania is present in peptides, and we do know also that this parasite may infect through the sandfly bites, Serpentoria also dogs and humans. Why it's important? It's important from two different perspectives. The first perspective is the diagnostic perspective, that is the fact that by immunofluorescence assay, which is the test that is considered by the WHO as a reference test for canine leishmaniasis, even if we know that there are many limitations there, it causes cross-reaction. It causes cross-reactions. It means that most dogs that are infected by Leishmania tarentulae may cross-react with antigens of Leishmania in the hyphae of Leishmania infantum, and so we may have false positive. And this is quite important also for the treatment, because we do know from the guidelines, if you have very high quality fibers and other clinical signs, laboratory alterations, which are compatible with or which are similar to those or which resemble those of the Leishmania infantum, you have to treat your animal. And the second reason is because of these studies that we conducted, that are the studies which demonstrated that peripheral blood cells, molecular cells of dogs may be infected by Leishmania tarentulae. It means that we know that the polarization of the cellular immune responsiveness of dogs is important for treating and for healing or for the development of clinical signs of leishmaniasis. So the idea is that if Leishmania tarentulae may cause a polarization toward the cellular immune responsiveness, we may have a cross protection, like an immune therapy, which may be a new perspective also for the treatment and for the control of canine leishmaniasis. Consider that vaccines are yet not fully available and are not resulting in the infection and in avoiding the infection by Leishmania infantum. So I think that that could be the final thing that we have next time we will discuss a little bit more about all the different issues, including the control of vector diseases, the control of vector diseases, because we have different strategies about this. Okay.
Thank you, Domenico.
Grazie. Because you are perfect, but I'm sure that
1 minute for a question.
It's a very quick one. No, it's just because you said that very important slide for me, like the anaplasma culture one, to the last 3 slides. So that's why it doesn't cast now. So I think it's very interesting that Ehrlichia canis human cases because, as you know, I work a lot on anaplasma culture, and we are realizing that, like, zoonotic cases are, sustained by more and more species. For instance, also anaplasma is now considered zoonotic. With also in Venezuela, they found a case or 2-3 cases, and so it's very interesting because the zoonotic range of species is expanding. So it's a very interesting topic. I have a question, like the paper you are publishing on the Ehrlichia caries is only based on the presence of the, the Ehrlichia in blood of the patient, or
No,
but in the human patient, it's like, did you do, for instance, did you measure the degree of replication in blood, or like, no, it's only like a
detection, because we have clinical signs.
It's a good start, but
Yeah.
that's
Thank you, Domenico. Okay, so let's skip to the next speaker, which is also from Bari, Professor Vito Martella, which probably also for his publication, and also he works for Italian Ministry of Health, for Italian Supreme Health Council since 2017. So please, Vito, we are ready. You can start. You have 20 minutes, and then some class for questions.
I want
Vito.
I want to need as much time as Domenico for my presentation of this. But that's like that was. So after following the presentation yesterday, also today, I realized that about 60% of my presentation has already been displayed.
But you can see for us.
Vito, il tuo, scusa, il tuo.
Sì, penso che devi fare così. Vai.
Okay, so I will not give you the definition of zoonosis. I will not tell you anything about this. I just spend some words on this because animal disease can impact on human health when they cause directly disease, but also disease of animals can cause economic losses and damage. So they can affect the economy either locally or globally. And also there can be change in the ecosystem. So this is the case of the rinderpest infection that was the driver of the origin of the foundation of the veterinary science in Europe. And so I made a list of health economic emergencies that we have been facing in the last years. And of course, it was invasion by alien species, and then a bunch of animal disease, animal infections. So invasive alien species, in Italy, we had a problem, for instance, with the Atlantic blue crabs and with new mosquitoes. And the Atlantic blue crabs was destroying the production of plants in northern Italy. And also we had problems across Europe, but also in Italy with African swine fever. And this is potentially a huge economic threat for our economy. And also we are facing the development of the H5N1 bee flu. There is a strain that is so the variant 2.3.4.4b, and this strain is causing problems in the US. This is the screenshot of the CDC. There is an ongoing state of break. And they found out that the virus can infect cows. The virus is spreading across herds by animal trading, animal movement. So it is not a case of a repeated spillover infection, but it is a strain that is circulating in these animals. The virus can be found in milk, and also cows are usually asymptomatic. They have all loss of milk production, general signs, but infected milk fed to cats can cause severe lethal infection. So when we have these health emergencies, we are posing a lot of questions, but sometimes it's difficult to find answers to all these questions. So as I said yesterday and today, we are altering some delicate balances, and also a major driver of these the emergence of these novel disease is the globalization. And some months ago, it was the problem of the onset in the Netherlands with a new strain, a new type of Pluton. And they claimed that the virus was arriving to the Netherlands by Italy, by Roma, with by train. The concept of traveling of the journey has changed over the centuries. So some years ago, it would be very dangerous. It would take years to go back home. And I love the literature describing the concept of the journey of traveling, the British literature. My favorite writer is Forster. And just figure out that they took about 2 months and a half for Cristoforo Colombo to reach the Americas. And in the 19th century, it could take at least 20 days to cross the Atlantic Sea. And so, as for improvisations, we are. I found out these nice pics of a Chinese town on the Yangtze River. You see that this is particularly hot. You see that this is a very narrow city constructed on a narrow canyon. And of course, global warming. There are some curiosities found in the internet about global warming, because the biologists are concerned that there could be some viruses emerging from ice, and also they were able to resurrect some viruses that have been sleeping for thousands and thousands of years. But of course, sometimes it's just a matter of casualty. And here again, the concept of one health that Domenico just told you what I wanted to say, so I skip this. But I want to say that I will focus on a couple of viral infections that have been at the center of our attention in the last years. I think that SARS-CoV-2 perfectly recapitulates the One Health paradigm. So when the virus emerged, it was clear from the beginning that it was a zoonotic disease. And most cases were related to a live market in Wuhan, in China. And subsequently, a number of bat coronavirus strains have been detected that are very similar to the human SARS-CoV-2 strain. And so we think that bats may have had a role, or either directly or indirectly, for transmission of this infection to humans. And these are some screenshots of wet markets in China. And as soon as the disease started spreading in human population, in March 2020, the disease was declared as a pandemic. So in April 2020, we started noting the appearance of this virus in mink farms. There were outbreaks across Europe, but mostly concentrated in the Netherlands and in Denmark, because there was an industrialized production of mink farms. And millions of animals were killed because of this. And the virus was also observed in persons. There were cases traced to contact with animals, but also were cases in the population. And the virus analysis of the virus demonstrated that it was a mean-derived virus. So this led to the shutdown of the mink industry in some countries. In the Netherlands, they anticipated the shutdown, and in Italy. And then there were some documents analyzing the risk of this virus. This is a tripartite document. And also the virus was circulating in other animals. So we had a hamster-related outbreak in Hong Kong. There were at least 50 cases of person-to-person transmission. And also, we realized that the virus was circulating, was able to infect other rodents. And what is curious that the early variants of SARS-CoV-2 were not able to infect lab mice, but the later variants were able. So this could potentially create a reservoir, massive reservoir of hosts for the virus. And also the virus has been documented in pets. There are hundreds of reports in dogs and cats, and in the late the variant phase, so in the late phase of the pandemic, it was possible to see also cases of reverse transmission to humans. And this is very interesting because in North America, it appeared that the white-tailed deer was also a host for the virus. This animal is common in North America. The animal has been infected experimentally with horizontal transmission of the virus, but no clinical signs. And it seems, this is very odd, that in this animal host, there are, you can find strains, variants that are no longer circulating in human population. So the virus is extinct, these viruses are extinct in the human population, but are still circulating in deer. And the virus has been, evidence for the virus has been also identified reported in Europe in following year. The concern that the awareness that the virus is now settled, has been found in several animal species, has been summarized in this risk report by CDC, and there are tables reporting the susceptibility under experimental and natural conditions. So in conclusion, SARS-CoV-2 is a pandemic/panzootic virus. Different skills, competencies are required. So this is fulfills the requiring the paradigm of the One Health, on my opinion. The other infection that we have faced in the last year was the monkeypox. We had an epidemic in 2022. It is a large virus. And the genome of this virus is very big, and the name derives from the fact that it was first identified in monkeys in 1958, but subsequently it was identified also in humans. And the virus is considered endemic in the African continent. Here I found a review recapitulating the epidemiology of this virus in Africa. And there are two strains. One of the strain, the Central African clade, has a case fatality rate of 10%. The second strain, the West African clade, is 3.5%. So the case fatality rate is lower. This strain is the one that sustained the epidemic in 2022. So these are this is a picture of the changing epidemiology of the virus in Africa across the decades. And in 2003, the virus also, there was an incursion of the virus in the United States. And what is interesting that since September 2017, in Nigeria, the number of cases of monkeypox, there was a surge in the number of cases of monkeypox. And all global East African cases after 2017 are related to the Nigerian basin. So also we observed change in the pattern of disease, and it was likely related to the termination of the vaccination for smallpox that was cross-reactive against other pox viruses. And the reservoir of this virus is not clear, but it is several species of rodents and small mammals could be the primary host, while primates, non-human primates and humans could be the secondary host. And it is interesting that bushmeat is recognized as an important source of exposure for this virus. So I found a video on YouTube and I made some screenshot of the Bashment market. And see that these women are having a nice conversation with selling grass cutters, antelope, deer, bush dog, pangolin, bush rat, and all sorts of animals. So these are, okay, hi, this is for you. You can also have a taste of python snake if you want. So the monkeypox in West African countries before 2022, you see we had a large cluster of infection in USA. And these, all the 47 human patients that were equally distributed between the male and female were in contact with the prairie dogs. These are mammals of the family Shuridae, and they are not canids, but they are rodents, the same family as marmots and squirrels. And the outbreak was related to the import in Texas of 900 small African animals of 9 distinct species. You can see the squirrel, the porcupine, and the mouse. So all the prairie dogs were sold in 6 USA states, and transmission was related to direct and indirect contact with prairie dogs that are a key aspect in US. So the epidemiology of the transmission of this virus is can be the zoonotic transmission, mostly in endemic areas. And also we can have person-to-person transmission, and this is these are occurred elsewhere. So the multi-country outbreak of 2022, the initial reports were from UK, and the first case was directly related to trading it, to traveling in Nigeria. And the other cases was not related, but immediately there was this anomaly that most cases were related to MSM patients. And at the same time, the virus was spreading in Europe. And this is the epidemic curve. You see that most cases occurred in August 22. And were distributed in the Americas and in the European countries. So in conclusion, monkeypox displays an unprecedented pattern of transmission in human population. There are marked epidemiological differences between the 2003 incursion into USA and the 2022 multi-country epidemic. And there were concerns for possible transmission of monkeypox to other animals reservoirs due to the viral pressure generated by human epidemic. Friends working at ISS in Rome were controlling wastewaters of the airport of Rome, and they found out the virus in the sewage water. So just to conclude some hints of our lab experience in Bari on animal viruses. We have long been working on human and animal caliciviruses. I am currently member of the ICTV committee for caliciviruses, the study group. So noroviruses are important human pathogens causing gastroenteritis in all age groups. And in 2007, we first discovered that this virus could also be harbored in carnivores. So we reported the presence of the virus in a captive lion cub. The story was funny because a couple of lions were reproducing, and after the third tentative, the cubs were dying with hemorrhagic enteritis. So they sent a sample to us for analysis, and we found out that there was a calicivirus. It was not the common feline calicivirus, it was a norovirus that was related to Alzheimer-like human norovirus. And in 2008, we reported the detection of this virus also in dogs, and also collaborating with USA friends, we found out the virus in cats. And there was literature on this topic. There were several studies, and also some researchers were able to discover actual human norovirus infecting dogs. This is a tiny study of 2020, and this is a 2012 studies from Finland. They started from the hospital. They asked the hospitalized persons with acute gastroenteritis if they had animals. Then they went sampling the animals in the household, And they found out that 3 animals were positive, and 2 of these were also with clinical signs. And they found out viruses that were circulating in human population, so human norovirus strains. And also, we had several examples of viruses that are being discovered in animals that are the counterpart of human viruses. So in 2018, there was a discovery of a new hepatovirus in domestic cats. And this is an analog of the hepatitis B virus. And this is the domestic cat hepatovirus. This is the human virus should be. I can find. Okay, it's here. So we started working on this topic, and then we starting from the hypothesis that dogs and cats share several viruses. We found out that also this virus was present in dogs. And also, we are working currently on an analog of parvovirus B. This is the only human pathogen, pathogenic virus, the only pathogenic parvovirus strain, and it's associated with the fifth disease, but also with other important problems. And we identified in cats a virus, in the retroparvovirus that is closely related to the human parvovirus B19. And so in conclusion, animal and human virome are deeply connected. Virus discovery, even of non-cultivatable viruses, this has been a very noisy problem for virology. Is now way much easier with unvirus PCR assays, with sequence-independent enrichment protocols and massive sequencing technologies. Interpreting the data is still tough. It is not easy. And finally, surprises are always around the corner. Thank you.
Thank you, Vito, also for respecting the timing. So we have some minutes for questions. Any round? Can you please come here?
Thank you, Vito, for your presentation. And it's not just a question, it's more a remark. So you mentioned monkeypox, and you know that I worked a lot on monkeypox, on pox in general. And yes, monkeypox is on the news. But we have many other vaccinia, and we have cowpox in Europe, and they are very neglected. So I'm just recalling what our colleague from Senegal was stating yesterday related to the fact that we don't look at what is already around, like neglected diseases. So we enjoyed a long time without pox, thanks to vaccination. But now what we are looking and what we are seeing is that they are increasing in incidence, but the problem is that human doctors do not recognize them because they look like many other diseases. They look like, for example, chickenpox, and so they don't gain us. And I think the big error last year, 2 years ago, was that MSN had monkeypox, but this is not true. So communication is very important when it comes to zoonotic diseases, and monkeypox and cowpox and vaccinia are just telling us that this is an interspecies transmission. I'm not sure that this is a zoonosis, because we have reservoir in animals, yes, and this will make a lot of difference when we want to eradicate a disease that has reservoir in animals. But the problem is that we also have cases in dogs transmitted by human patients. So a reverse zoonosis, because it's an interspecies. So do we still have, in your opinion, do we have to carry on talking about zoonosis with an anthropocentric point of view, or we wear just the glasses of a microbe that do not see any difference in any animal that can jump? Well, yesterday we heard about reptiles, which is very far from me.
Yeah.
But yes, so what do you think about this concept of zoonosis? Do we have to work on it, in your opinion?
Thank you for the question. I think that you focus on the on the point that we were discussing also with Ambassador, that there are zoonoses, but there are also viruses that are derived from animals. So I don't know which is the proper definition, but I agree with your concept that the borders are very fainting.
Do you think that we can maybe draft here an opinion paper on this?
I think yes, but you should.
Why not? Yes, maybe. Why not? Think about it.
Yeah, thank you to both. Any other question? What I would like to stress regarding this.
Actually, since my name was. No, just to be, we were talking about the use of zoonosis here. We talk about zoonosis, but technically speaking, like epidemiologically, a zoonotic disease is always characterized by all the cases deriving with contact with animals. But actually, many of these zoonotic diseases manage to gain human-to-human transmission. So technically, they are not zoonotic anymore. I mean, we cannot. They are like something more, as you said, transversal and big, because they go to human, they go to animal, they jump to another species. So as people that work with, in the vet environment, that we know, and for us it's normal, but when you move from, to other people, they don't understand it. So probably we should, an opinion paper would be very nice, I think, about discussing the true idea of zoonotic, transversal, and animal-derived infection. But I also have another point to make, if I can, because your presentation was very interesting. It was really fast, but can you go back 1 second to the list of you showed for like 2 seconds a list of animals in which
I changed it.
people found. No, we cannot go back. Okay, don't worry. You presented a paper in which they present results on different wildlife species and COVID-19.
It's a CDC risk assessment.
So I think that also that data, we should take them and consider them very careful, because in some example, the effect of telling to people that while animals were infected with COVID-19, basically have the only effect of demonizing the species. For instance, we are doing here there is my PhD student. She did a lot of work. She, I think, tested more than 1,500 hedgehogs from Denmark and the UK. We just finished in June because someone published that hedgehogs could be a reservoir for COVID-19. So, this species was starting to be perceived as a pest, And so actually we realized that, we did a huge amount of work using classical molecular biology techniques, and then we went on PAN, Corona, the PCR, and then we did some NGS to be sure, but actually the only virus that is circulating and is significant is the edge of the coronavirus, which is, we also sequence the entire spike to be sure. This is a paper that will come out in screening fall. We didn't have any possible connection with human infection. So I think we should be careful when we give news about host and possible reservoirs or also vectors, and so this is a point that come out also from your presentation.
I didn't get a question.
It was more, this is a workshop, so I think we should, the most important thing is talking about what comes into our minds. So I'm expressing my frustration about something.
Okay, thank you, Alberto. Thank you, Vito. And please welcome to Paloma and Moréna. Paloma Kiwan, Moréna Gasparine are two young researchers, PhD students from Corsica. Paloma comes from Marseille University, associated with the University of Corsica, and Moréna comes from University of Corsica, so a sister island. They are part of the team of Alessandra Falchi, a Sardinian researcher that works in University of Corsica, and they reached a very important goal this year, making the first isolation of Crimea Congo fever in Corsica. So we are nearby here, and so we would like to see your experience, and also we have a lot of questions because of the fear here is, but probably CCP is already here in Sardinia or not. Okay. Good work.
Thank you. So, hello everyone. I'll be presenting today with my colleague Moréna some of the research in our event team directed by Alessandra Falchi. And in my part, I'll be focusing on the investigation of the Congo hemorrhagic fever virus in Corsica via a One Health approach. So, Congo hemorrhagic fever virus is an enveloped virus of the family Neroviridae. His RNA genome is divided into 3 segments, S, M, and L, resulting in a complex replication process prone to errors. And this leads to a genetic diversity and 7 different genotypes that are correlated with their geographic origin. And as we can see on the map, one genotype can be present in different regions. So this endemic virus has been identified in over 30 countries worldwide, with 10,000 to 15,000 cases reported every year. This widespread distribution can be attributed to intensified testing, but also to the broad distribution of its primary vector, the Ialoma ticks, which exhibit tolerance to diverse mechanisms, to diverse environment, and also a capacity to feed on a variety of hosts. These ticks can spread to new regions through transportation via migratory birds, and also through legal or illegal animal trade. So this virus can infect a wide range of animals. As humans, we are also susceptible to infection, either through tick bite or through contact with animals and individuals carrying the virus. In animal population, this virus causes little to no harm. However, when it infects the humans, around 10% may experience symptoms. And this disease primarily presents as a non-specific febrile illness, but it can quickly progress to an hemorrhagic phase, with mortality rate reaching up to 30%. And people that are at risk are those who frequently interact with animal and ticks, such as farmers, slaughterhouse workers, veterinarians, and this population can serve as a sort of early warning system for the spread of this virus. So we cannot see, but there's a map here. Okay. So in Western Europe, there's growing concern about the emergence of CCHF disease, certainly after the reported cases in Spain and in Turkey. And Corsica is a Mediterranean island, and it faces also an elevated risk of this virus, certainly due to its Mediterranean climate, the localization on the avian migratory route, and also the abundance of Ialoma ticks, which is present in Corsica since 2005. So animals that are considered good virus amplifiers act as good indicators of the virus circulation. This is why antibodies were searched in animals between 2014 and 2016 and detected in 13% of cattle, 2.5% of sheep, and 3.1% of goats, indicating prior exposure of the animals in Corsica to this virus, certainly cattle. Also, between 2016 and 2020, more than 8,000 ticks were collected on domestic and wild animals and analyzed, but no detection of virus was reported. So the objective of my thesis entitled TICTAC is to strengthen the preparedness for tick-borne diseases emergence via a One Health approach. And I'll be presenting today the results on Congo hemorrhagic fever. So since 2022, we continued the surveillance on tick. We collected more than 5,000 ticks from cattle in slaughterhouses in Corsica, as shown on the map. Ticks were then identified and subjected to molecular analysis. 119 ticks detected at 2 different sites in Corsica were positive for the virus, and 99 were detected on the same animal, which marks the first detection of this virus in Corsica, an established circulation in the region, and an evidence of infection in cattle. We also sequenced these positive ticks using next generation sequencing, and the result showed that the circulating strain in Corsica belongs to African genotype 1, with sequences identical to those identified in Senegal, but it differs from the strain that circulate in regions around Corsica, like for example in Spain and recently detected in France. Also, in parallel, we conducted a seroprevalence study involving two distinct groups of individuals. The first group consisted of the general human population. So we collected more than 2,000 serums from the medical laboratories in Corsica. And the second group consisted of high-risk population. So we had farmers, slaughterhouse workers, veterinarian, and field personnel. 201 participants underwent capillary blood sampling and also responded to an anonymous questionnaire covering a wide range of indicators. After that, the serum from both groups were analyzed using ELISA, and antibodies were detected in 2 participants from the general population and 1 participant from the high-risk group, which was a slaughterhouse worker who had reported being bitten by ticks in Corsica and reported experiencing symptoms after the bites. The positive serum were then tested using by seroneutralization in the P4 laboratory in Slovenia. And among our 3 positive samples, only the slaughterhouse worker had neutralizing antibodies. For the high-risk population, the questionnaire revealed some eye-opening insights. Like, for example, around 66% of participants reported tick bites in Corsica, and among them, 20% reported symptoms after tick bites. Also, the majority of participants don't take precaution against ticks, practice hiking, and among those who hunt, the majority practice evisceration. Also, the primary tick bite-related activities reported by participants was animal-related activities for farmers, outdoor activities for ranger, pets-related activities for slaughterhouse workers, and leisure activity for veterinarian. And for the primary tick removal method reported, the majority of farmers and slaughterhouse workers remove ticks by fingers, and the majority of rangers remove ticks by tick removal tweezer. Further multi-analysis pinpointed some variables that are related to the risk of tick bites, like for example, farming, a career duration for over 10 years, horseback riding, and hunting. This shows that we should take into consideration occupational and non-occupational related activities when studying the prevention of tick-borne diseases. Till now, no human cases have been reported in Corsica. Possible explanation can be the inadequate investigation into human infection, since this disease can often be mistaken for summer flu, and many cases go unnoticed. And also, it could be the circulation of a less severe strain in Corsica. But this similar situation have been reported in other countries, like for example in Spain and Greece, where the first detection of the virus was reported years prior to the first emergence, the emergence of the first case. So this disease in Corsica should not be underestimated, and we should be aware of possible future autochthonous cases. And finally, these results emphasize the need for ongoing surveillance, certainly on a higher number of participants, public health education, and preventive measures. And healthcare providers in Corsica should consider this virus in patients who had hemorrhagic fever, and certainly those who reported a tick bite and animal contact in summer and spring. Through these measures, so we can strengthen our ability to anticipate and effectively respond to potential outbreak. Thank you.
So thank you, Paloma. And now let's begin with a little context about Corsica. So Corsica is a French Mediterranean island located on the Aegean migratory road. It has an important ecological and climatical diversity where the interactions between human, animals, and environment are constant and increasing in the summer season. All those characteristics make the island a favorable place for the development of many tick species and pathogens. The important ecological and climatical diversity is changing and become one of the key issues of our times. Because of the global changing and especially the global warming, ticks can extend their distribution areas and their abundance all over the island. As Paloma presented to you, this is why we wanted to study the risk of tick-borne pathogen emergence in Corsica. And as Paloma presented to you, her study adopts a One Health approach, focusing on animal and human health. This is why we wanted to complete our project by undertaking another TLS project focusing on animal and environment health. So in the Mediterranean regions, we don't have many study or data about tick-borne diseases and their link with environments. And this is why my thesis project is based on three main axes. And the first one is to characterize biotopes, tick biotopes. At small scales, spatial temporal scales, that mean where ticks can interact with the host. And this is interesting to study ticks biotopes because they determine the survival and the abundance of ticks in an environment. The second axis is about ticks collection, and then the third one is about tick analysis. So to characterize ticks biotope, we decided to sample 43 municipalities all over the island based on the average temperature and rainfall, but also on the vegetation stages, to try to include as much biotope diversity as we can. And for the choice of which biotope we will investigate, we based our choice on the literature. And we choose the forest ecosystem, the meadow or plain ecosystem, and the ecotone, which is a transition area between two ecosystems. In the 43 municipalities, we are searching all those biotopes, and if at least one of them is found in the municipalities, we characterized it by 1 meter's transect and implemented with 3 quadrats. For each quadrat, we measured 12 variables, and this allowed us to collect information about the site localization, but also on abiotics data and biotic data. Each of the 43 municipalities were 2 times investigated in spring and in summer because it's the season where ticks, the tick activity is the highest. So all this field work done in 2023 allowed us to collect small-scale environmental data, which could be completed by micro-environmental data such as atmospheric temperature or rainfall, but also on the NDVI index. In parallel with the tick biotope characterization, we collect ticks from 3 different methods. The first one is directly by the characterized biotope by using the tick dragging method. So this method consists by dragging a white sheet over the vegetation, and it will act like a mechanical lure where ticks can climb thinking it's a nose. With this method, we collect 275 ticks from 6 different species in 30 municipalities. Here, let's focus on the tick Paloma marginatum, which is the main vector of the CCHF virus. we can see that we only collect 4 Yaloma ticks, and this is certainly due to the fact that it is a hunting tick, whereas the others are standing in the vegetation, the passage of the nose. So we will try another method to catch Yaloma in its habitat. The second tick collection method is to collect from horses and cattle. So we almost collect 6,000 ticks in 2023 from 8 different species. And you can see that Yaloma marginatum is not found in the same proportion than with the environmental methods. So this confirms us that with a better environmental collection method, we can catch so much more Yaloma in the environment, but also that using different collection methods is the best way to assess tick diversity. Moreover, thanks to cattle identification number, we can easily know in which area tick were before parasiting the host. Finally, we collected from wild small mammals and migratory birds. And as a suspect of research is new and ongoing, I can only present you the results for the migratory birds. We collected 148 ticks, and as you can see, only Exodus ricinus was found. It's interesting to collect ticks from birds because it serves as a mechanical vector in the CCH dynamic and make it possible to monitor new tick species from other continents and therefore new pathogens. Once we've collected them, we have to analyze ticks, so biomolecular detection for the presence of viruses of public health interest. As Paloma presented to you, we detect CCH virus in ticks from cattle, and we didn't detect CCH in ticks from environment, but this is certainly due to the small size of vector analyzed. In the next months, we will detect CCH in ticks collected in 2024, and we also want to analyze them for other viruses like West Nile virus or tick-borne encephalitis virus. We want to analyze tick by using new generation sequencing to assess tick's viral diversity and also their genetic diversity according to their localization. And we had analyzed tick by microfluidic shift to detect the presence of bacteria and parasites in ticks from environments. And among the 36 pathogens found, we searched. We found 10 of them, and now I have to study literature about species and stages related to those pathogens. Until 2024, we are able to collect blood samples from cattle and birds, and this permits us to save time and to increase the detection efficiency of our surveillance system. To conclude, studying tick-borne pathogens in a multidisciplinary way is the best way to have a realistic view of the consequent stages. And I hope this work will implement the environmental part of tick life cycle knowledge in the Mediterranean region, but also provide us an overview of tick species, their localization, and also the tick and pathogen diversity and their circulation. I hope this work could be used in modeling systems to identify areas at high risk of emergence in Corsica. Thank you for your attention.
So any question? Domenico?
First of all, congratulations for this very interesting work and investigation. So I have some questions I suggest, if I may. The first one is when you show the results of the collection, it's quite expected that you will find any or just a few by driving. And I would have suggested you to do it in two different methods that are by carbon dioxide at the attraction, or by collecting it by themselves under the stones and so on. In that way, you may have an estimation of the population of Yaloma marginal. This is because otherwise you cannot compare. Just cannot compare. Your results on the wildlife is very close to our results in Porto that 20 years ago in Basilicata as well with Felipe and Pastornes, and are very comparable. Also with Alessandro Facci, who is not Alessandra, Alessandro Facci, because he came here to my place because was a student of Professor Scala and Barcasia, and he worked on the migratory birds. And we found just a few specimens of Yaloma. The second is a question. And the question is about the tick characterization.
We are okay.
Also for question, no, it's a tick characterization because you told that molecularly you are going to detect to identify things. So did you check whether is always this rufipes, Yaloma rufipes, or Yaloma marginatum? Because it seems that you have different host susceptibility in their capacity, vectorial capacity for phenomenonological field. And that's something that you, if you didn't do it, it would be also interesting for you to more in depth characterize this in order to check the occurrence of viruses eventually.
Okay, thank you. I think we checked if it's Yaloma marginatum or ripifes, but we didn't have a Yaloma ripifes in Corsica. We have Yaloma scripens and Yaloma marginatum, and no Yaloma ripifes was reported in Corsica.
Before we were checking just the morphological keys, but since 2024 we started also, if we have any suspicion, we are analyzing by sequencing the text. So S says S genes and tox. So we can be more certain of the species that we are seeing. And for the carboglass, Moréna has started this.
I tried to catch them with a carbon trap, but it didn't work. So we wanted to try another method, but one of them is to stand in the vegetation and catch them on the floor. Yeah. Thank you.
Okay.
You go first.
Gaetano e Alberto.
So firstly, congratulations. Love the aim of the project, TikTok, very nice. I have a question regarding, I didn't have clear if the pools you have of ticks, you had of all of the species you were looking for CCHV, you find positive pools or just for Yaloma marginatum?
No, we find 99 were on the same animal, but
Of different species of ticks.
there's a lot of species. There's Yaloma, Epicephalus sanguineus pulsa, and Hemophysalis punctata. But we have, I think, a lot of species because it's the animal that was very, so it's not the blood of the tick, it's the blood of the animal. So we don't have any information about the vector
The competence of the.
competence of the vector.
And my second question or suggestion would be, as I am the rectal guy, have you checked for testudo tortoises in Corsica to see if they have also infestation of Yaloma or artificial ticks?
No,
Given that they have some, can have a cryptic cycle of hematic fever.
no, we didn't, but I think it's a great, for after the researchers after, because we started this year on birds. And it could be a good idea, thank you.
Martella said always Yaloma.
And also consider that there is a risk of importation to Europe of Yaloma aegyptum, which is typical from tortoises because of the illegal trade. So
Okay.
there's some cases already. Thank you.
Okay, thank you.
Get done.
Do you have any hypothesis for the origin of the virus? Do you have importation of the live animals in the island like cattle? Your birds, other animals, but what is your hypothesis for the origin?
We don't know the origin. Cattle, the majority of cattle in Corsica are not imported. They are locally, yes, elevated.
Yes.
But for now we don't have any response. But in the next month we will maybe sequence the ticks that were positive for these maybe the Yaloma, and we will see the origin of the sticks. So maybe we can know from where it came. Maybe we can have some possible explanation of the origin of the introduction, because we sequenced sticks before, not these sticks, from the first surveillance between in 2016-2020, and the species of ticks were from Tunisia and Italy. So it's on the avian migratory route that is different from the ticks that arrive to Spain. So maybe this is why we have strains that are circulating in Corsica different from those in Spain, but we are not sure yet. We will continue investigating.
Yes, so Paloma is you, right? Thank you for the interesting talk. Honestly, both of them were really interesting. So I have two questions. The first question is for you, and it's like, as far as I understand, so you have like this positivity for Crimea Congo virus in ticks, and you also have cases of like human which have been bitten by ticks and they are symptomatic, but you're still working on correlating these two situations, or you are evidence that some of these human cases were related to Crimea Congo infection?
No, we're not sure that it's related
So that
to Crimea
I
Congo.
understood correctly, right?
Yes, because it's before, and the slaughterhouse worker just remember that he had symptoms, but he don't know which month, which related activity, so it's general.
So the second question was like, what serological test? You mentioned ELISA, right? Is that like a full antigen ELISA, recombinant ELISA, or do you?
Yeah, we
Can you
use
give us more days?
immune kits. It's and we use two kits, immune, and but these results were based on the kit IDVET, which is the total antibody.
Okay, so that's
antibodies.
Alessandra.
Because
we were wondering if you could take into account also some cross reaction, because the test, we know that.
Because we had more positivity with immune, because when we tested with the seroneutralization, all the immune positive samples were not.
But don't worry, it's a lot of work. I mean, I love, so don't be scared. It's like
us also because we had the same result.
Yes.
At
it's very interesting, I'm from Sardinia, I'm going to do something on that. I want to check if we have it. The second question is for you. You showed your last picture, you showed some pathogen which you found actually in ticks. And I saw anaplasma and my heart was like boom, 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 boom. And so did you check for different species and this is what you found? Yeah. Or like, because in Corsica, for instance, you have also, I'm pretty sure you have anaplasma capra, which is also zoonotic. It was found in Corsica and some others. So my question is, did you check like different species or not yet?
Not yet.
Anaplasma touch.
Yeah, not yet. I can check my results if you want.
Yeah, because just a suggestion, you are not going to go like very far with Anaplasma phagocytophilum, which is in the Mediterranean area, it's like very low prevalence. But there are many other which are emerging in the genus Anaplasma, and that are really interesting. I think you should go there and you will find interesting things. Okay.
Yeah.
Thank you.
Thank you.
Thanks.
Okay, thank you, Paloma. So we have 30 minutes for coffee break and we come back for the fourth session.